Hello everyone, in this video I'll be explaining you the problem cookies and greedy Takahashi. So this was asked in AtCoder beginner contest 471. So let's read out the problem. There are cookies at n positions on a number line. The coordinates of the ith cookie is a of ai basically. So Takahashi is initially at coordinate 0 on the number line and repeats the following action until he picked up all n cookies. Okay. So action is move to the coordinates of the nearest cookie from his current position. So this is very important. I'll tell you why. If there are multiple such cookies, the one with the smallest cookie coordinate um, we have to pick. Okay, and pick up that cookie. Find the total distance Takahashi travels until he picks all the cookies. Okay, so n is from in 1 to 10 power 5, and this cookie can be at position from minus 10 power 9 to 10 power 9, and the cookie can't be at 0th position. That's what it means, and all the positions of the cookies are distinct. Okay, all input values are integers. So yeah, let's understand the problem statement. So this is problem number C. Cookies and greedy Takahashi. Nice name, by the way. So that said, in the problem statement, we have a number line. Okay, we have a number line. So I think everyone knows from the math, number line is the form. Um, it is a positive x index. Okay, we call it as x, and this is basically x dash it is negative. So the numberings are this way till infinity, and here the numberings are minus 1 to minus 3 up to infinity minus infinity. Okay, this is the number line, and Takahashi initially is at position 0, and what this said is we have n cookies placed at positions. Okay, so it can be placed at position a of I, okay, where I is from 1 till n. This is basically index, I mean the array index, whatever array we have a. Okay, it's like a0, a1 up to so on a n minus 1. So if we take 0 based indexing, it will be 0 till n minus 1. So AFI denotes the actual coordinate where that cookie is. Let's say it is at coordinate number 5. This is for this 5. Okay, so this can be this thing. And they have said no cookie is at position 0. So we don't have any cookie at position 0. As in the said question, AFI is never equals to 0. And all the cookies we have, right, at positions, they are at different positions. So it's like distinct. All the cookies are at distinct positions. So we cannot have two cookies at, let's say, position 2. This is not the case. Okay, we can have cookie at position 2, and we can have cookie at position 3, not on the same location. And we cannot also have cookie in between, like minus 1.5. So this is not the case. So what they're saying is this is the problem statement. And one more important thing, as I said in the question, I'll be explaining you later. So that important thing is, um, they have said the whatever locations we have, right? 1, 2, 3 on the number line. This is x, and this is x dash, minus 1, minus 2, minus 3, up to so on infinity. So what they've said is, since let's say Takashi is starting at 0 position initially, and we have cookie placed at this position and this position. Okay, uh, we can think of this. So from the current position, he can move to a cookie wherein the distance is less. So this distance, if you see, it is 2, and this distance, if you see, it is 3. So he will not move to this cookie first. He'll definitely move to this cookie first. So that's the thing they've said. Uh, and the reason I'll tell you why I'm giving importance to this in the question in the contest what I thought, and then eventually that was false. I'll tell you that also. So now other case, if you consider, let's say this 0, this 1, this 2, this minus 1, minus 2. Let's say I mean cookies are placed this way. So initially Takahashi is position 0. So here if you see the distance is 2, and here if you see the distance is 2. So which one should he pick? He will be picking up the cookie which is having lower coordinate. So minus 2 is lower than the 2, right? So he'll be moving towards the minus side. Okay, so yeah. First, initially what I thought was in the problem statement, whatever they gave, 1, 2, 3, let's say it is 5, 4. So let's say one cookie is, we have multiple cookies. It's 2 minus 3. Okay, so initially Takahashi is at this position. What I thought is, um, okay, let me put one cookie here and this cookie let me remove. Then it will be good. Okay, and we have cookie 1 here. So initially what did I thought? From Takahashi's position, we will calculate in the positive side what's the farthest cookie. So from here, if we see the distance is 5, and here this side, negative side, it is 3. So what I thought is, let's go to first negative side and pick up all the cookies. So the distance travel will be here 3, and he'll come back again, it will be 3. Then he'll be moving other side, and the distance will be 5. So total distance is going to be 3 plus 3 plus 5, which is 11. So this is not the case. In the question, they've said from the current position, whatever Takahashi is at, from that position, if there are cookies either side, definitely there'll be two cookies either side, and it may happen that we have just on the one side. So in that case, we have to move that side only. So if there are on the either side, so whichever distance is less, that we'll have to pick. So in this case, first he'll move this case, right? First he'll be moving here. Okay, and then when he's at this position, here the distance travel will be no one, because from 0 to 1 he moved, so it will be 1. So now the Takahashi's current position is this, and this is not the position. From this position, now if you see, this cookie is at distance 4, and this cookie is at distance 1 to 3. So now he'll be moving this side, so it will be plus 3. Now Takahashi is at this position. Now if you see, from this position till this position, what's the distance? It will be 5 plus 2, which is 7. Okay, and from here it will be just 1, so he'll pick this cookie now. Okay, so plus 1 will be adding, and then from this position he'll pick this cookie, so we have to move like 8 distance, it will be 8. So total it is going to be 13. So I think you have understood, like we should not move one side and then pick up all the copies and then cover the other side. It's not the case. From the current position, whichever cookie is at smaller distance, there we'll have to go. Okay. So how do we solve this now? It's basically greedy. Okay, greedy approach we can say, or also we can say it's just an implementation. Find the total distance traveled. So yeah, it is not asking like minimum distance or something like that. If it were like minimum distance, then we would have followed that approach, whatever I was saying, key moving one side and then moving to the other side. Okay, so yeah, we have to find uh, the total distance travel, and it is not a greedy problem also, we can say it's just an implementation. So first things first, what we'll have to do, we will take n indices, so we'll maintain two vectors. Okay, one will be negative and one will be positive. Basically what I'm trying to do is, we have a number line, so this is positive and this is negative. So wherever cookie is present, right? So on the positive side, since cookie is never present as 0, so yeah, we have to maintain only 2. So the positive locations, whatever we have, will be storing. Let's say in this case we have at second position, we have at fourth position. This will be storing. Let's say we have here this way. So we'll be storing -3 and then -4. Okay, and ordering is maintained. So whatever is at positive, we'll be putting into positive vector, and we'll be sorting increasing way. We'll be sorting in increasing way, and whatever negative is there, we'll be sorting in a decreasing way because the magnitude is important here. So -4 is lesser than -3, but magnitude wise, from zeroth position, it is far right. It is like fourth distance, and it is like 3 distance. So that's the reason we'll be sorting in a decreasing way, and we'll maintain a current variable. Let's say current when the Takahashi starts collecting the cookie, he'll be at position 0. So current will be 0. So now this sorting the vector is very important. So when you have sorted that from the current position, he have now, if you see two vectors, these are the two cookies that are then are at the nearer distance, which is like in the positive case, it is a present 2 distance, which can be found from here, and in the negative case, it is found at the distance 3, which can be found from -3. We'll be just taking care of minus. Okay, so that's the reason sorting is important. We have to do sorting. Now we will take two variables. Okay, one I will be pointing to positive. Okay, and j will be pointing to negative. So we'll take a loop. We'll say while I is less than positive size and j is less than negative size. It's basically size of the vector. So now what we have to do? We have to calculate two distances because we have the cookies on either side, because this condition is holding good, right? So we definitely have elements in the positive and negative vector, which means we definitely have cookies on the either side. So we'll take distance 1, we'll call d1. Initially, let me set it as 0. Now distance 1, what I'll be calculating is I'll be calculating on the positive side. So I'll be checking if my this current position is lesser than equals to 0. What do I mean by this is that, let's say my current position was somewhere here -2, and he's moving towards the right, towards the positive side. So in that case, whatever distance is of that cookie, it is from 0 based, right? So it is like 2, and this -2, like current position is -2. In order to reach to 0, he'll take 2 again distance. So that's the reason what I'll do. I'll be checking if it is on the negative side, it's like 0. We are taking this positive, but Takahashi is on this side. So in that case, this distance is also taken care, right? So in that case, in my distance, what I'll be adding is absolute value of uh, the current position. Okay, the absolute value of current position will make sure he's moved to the 0th location, and from there he'll be moving to the positive. So it will be positive of I think you've understood. Then I'll do I plus plus. It's like we have taken this cookie now. I'll move I ahead this way. Okay, this we have done. Else, if it is on the if current is greater than 0, okay, it will be that case. It's like Takahashi is at this position and he wants to calculate uh, the cookie which is at this position, and it will never be a case wherein cookie is here and Takahashi is at here, because we have sorted the array already. Okay, since we have already sorted, this case is never possible. We will be moving one by one from low in coordinate to the higher coordinate. So if this is the case, then what's the uh, distance he'll be traveling? The distance travel will be basically, what is the position of this? It will be position of I and minus it will be current position. Okay, okay, yeah, and then we'll increase I. And also don't forget one thing, to make sure your current now, since he was here and now he moved it to here, so your current will be positive of I. Before increasing I, make sure this is done. So let me write it here correctly. So it will be positive of I. He's moved to this position now, and then I will have to increase. Okay, okay, so you have understood, right? So this will be distance. Now similarly distance 2 will be it's like Takashi is very similar, let's say here, and he wants to pick a cookie which is on the negative side. So in that case again we have to check if your current is greater than equals to 0, which means he is on the positive side but he's calculating the negative side's cookie. So in that case your distance 2 will be basically this distance, which is like this position is a current, right? So it will be current plus, and this is the position, so it will be absolute of negative of j, because when we are calculating the negative coordinates cookie, so it will be j indexing. Okay, so negative of j, and then your current will be negative of j, and then you have to increase j. Similarly the else case will be, it's like Takashi is on the negative side only, and he is picking up a cookie which is on negative side. So in that case, his distance to is gonna be, okay. So it will be absolute value of negative of j. This is like from 0th index we have taken, and this is his current position at 0 index minus current if you do. So he'll get this total distance traveling. Okay, and your current will be negative of j, and then you'll have to do j plus plus. I think you have understood. Now you have distance. I mean, Takahashi was somewhere and he was picking a cookie from either side. So we have two distances. Now we'll have to check, since distance to whatever we're calculating, right? This is of the negative side, right? So in case of both having at equal distances, so in that case we'll have to pick a negative coordinates cookie. So that's the reason I'll check if d2 is lesser than equals to d1. So we have to move towards the negative side, and don't increase this I and j pointers here, because my bad, we are just calculating the distance, so we are not picking up a cookie right now. So when we pick up a cookie, in that case we'll have to do, so here we're doing a picking up operation. If distance 2 is lesser, so we are picking up the negative cookie. So when we are picking a negative cookie, in your total distance traveled you'll be adding d2, and since you have picked a negative, so j you'll be increasing. It's like you have picked this, now you'll be picking the next cookie available. Okay, else your distance is gonna be d1 and I will be increasing. It's like you have picked the positive side cookie, and next cookie you're gonna pick, so it is I plus plus. So yeah, that's it. And then it may happen that you had one cookie here and you had like three cookies here, and you have picked up this cookie, and then this cookie you have picked up, and there are two remaining cookies. We don't have any cookie on the left hand side to compare. So that's the case, we'll have to again check if your I is less than sorry, I, yeah, correct, I is basically pointing to positive size. So in that case simply you'll have a distance 1. Initially it will be 0. Now again we'll have to check same thing again, current. If your current is lesser than equals to 0, same thing, like whatever we had, this we'll have to copy. Let me just copy. Mm, okay, from here, can we move to the next slide? Let's check. I think we can't move. So it will be same thing. If current is lesser than equals to 0, so it's like current is here. I mean Takashi is here and he's picking up this one. So in your distance one, you are going to add absolute value of your current because current is negative and plus positive of I. Okay, and your current will be positive of I. Okay, these things you have done. And in this case, simply you just increase I plus plus, and in total distance, you're going to add D1. So this is case of if there are cookies remaining on the positive side. Similarly, it will be if there are multiple cookies remaining on the negative side and there are no cookies on the positive side. So it will be same thing. It is going to be if while uh, j is less than negative dot size, so your distance 2 is going to be initially 0. Again, you will be checking if your current, your cookies are here, but currently let's say Takashi is at positive side. If it is greater than equals to 0, so your distance 2 is going to be your current plus absolute value of this negative of j, and your current will be now pointing to negative of j, right? And j you can directly increase now because we don't have any comparing element like on the positive side and negative side. And in the total distance you're going to add d2, and at the end you have to just print the distance. That's it. So yeah, I think you guys have understood um, the algorithm, how we are solving this. So let's try to code it up. So in the problem statement, they'll give n and cookies. Okay, they've given n, we have taken n. Now I'll be taking two vectors. As I said, it will be positive and then negative. Now I'll be running a loop. Basically, I'll be taking all the n cookies. I'll be checking if that value is greater than 0, which means it will be in positive side. Else it will be negative side, and we don't have value as 0 as said in the question. Okay, and after this we have to sort the positive in increasing order. So it will be positive dot begin, positive dot end, and as I said, negative will be sorted in decreasing order because magnitude matters. uh yeah, R begin, I'll do it in reverse way. Once you have sorted this, I'll take two pointers I and j, which is initially 0. I is basically pointing to positive and j is pointing to negative. While your I is less than positive dot size and j is less than negative dot size, which means we have cookies on both the sides. Since we have cookies on both the sides, we'll have to calculate the minimum distances. So d1 is like positive distance. Okay, initially let me call it a 0, and I'll be taking one more variable. Let me call it as current. So initially he'll be at 0th coordinate, Takashi. So we'll have to check if this current, since we are calculating the positive distance, we'll have to check if this current is lesser than equals to 0. So what we'll have to do is we'll have to add uh, the absolute value of this current when you are adding, which means you have Takashi from minus current position to move to 0 position, and now you'll be positive of I. Okay, and your current position is gonna be um positive of I. And this we have to do not do initially because we have not chosen like which cookie we are choosing. So current position will not be, you know, taken care right now. Else the if current is greater than 0, which means it is on uh, the cookie that we are taking is on the positive side and Takahashi is also on the positive side. So in that case, your answer will be positive of I minus current. Similarly, we'll have to calculate distance d2 and we'll have to check if your current is greater than equals to 0, which means Takashi is on the positive side, but we are calculating the negative sides, cookie, we are taking that. So it will be distance 2 will be um, whatever current you have plus absolute value of negative of J. And else it's like both are on the negative side. So your d2, I mean distance is gonna be absolute value of you can take current minus negative of J. And now we'll have to check if your distance to which is on the negative side is lesser than or equals to, even if it is equal, so we'll be taking negative sides. Okay, so your total distance, I'll take one variable t distance, let me call it is like total distance. So total distance is going to be d2 since d2 is smaller, and since you have chosen the negative sides cookie, j is going to increase and your current position is going to be negative of j, else it will be other case. So total distance is going to add with d1 and I is going to increase and current position will be positive of I. And before increasing I and j, do this thing. I mean, you have chosen the ith cookie, so he'll be at position I. Then you have to increase I. In this case, basically j. So once you've done this, and now we'll have to check if I is less than positive dot size, which means it's like we have cookie only on the one side now. Okay, if we have only on the one side, so in distance one initially will be 0. We'll have to check if your current is lesser than equals to 0. Same thing basically we'll have to copy. So I'll just copying. Okay, once I've done this, so now here we don't need to compare d1 and d2 because we don't have a cookie on the negative side. So simply in total distance, you are going to add d1 and your current will be positive of I and you are going to increase I. Similar case will be with j, negative side. If we have cookie only on the negative side, so we will have to do this thing. Okay, now in total distance we'll have to add d2 and your current position will be negative of j and your j is going to increase. At the end you'll have to display total distance. Let's try to run it. It's running fine. Let's try to submit. Okay, this will give you wrong. I know why it is. My bad. So since n is like 10 power 5 and the coordinates will be 10 power 9, so if you multiply these two, it will be 10 power 14. So whatever distance the Takashi is traveling, it will not be in the this range. I mean, it is a range, so it should be long. Okay, so I have already defined long as LL. So total distance will be LL. Mm, Yeah, this should work. Yeah, let's try to submit now. So yeah, it got accepted. So yeah, that was it about the problem statement. And if you try to analyze, time complexity, so we have n negative and positive, coordinates, and it is total of n. So this sorting will take n log n, and this is like n O of n, and this is like also O of n only in total. So basically time complexity is depend on the sort function, so n log n, and space complexity is like we are using two vectors, and totally it will include n coordinates, n cookie coordinates, so it is O of n. So thank you guys for watching the video.